Right, we're in the battery shed and I'm just checking things. It's the first bright, sunny, cold day we've had for quite a long time. And we're charging at 20, just over 20 amps on the solar, which is 1 kilowatt. Which it should be more than that. And I've looked at various amp meters. Yep. I'll just check this one because it can stick. Oh no, it's good. Right, let's have a look at these charge controllers. So that's interesting. That one's doing 5 amps, 5.5 amps, and the other one, and I don't know whether we're about to see, we probably can't, but it's doing nothing, no amps. And instead of the smiley face, we've got the nighttime view. I'll just move the camera. There. So, are those panels in full sun? Have we got a problem? First of all, I'm just going to check the voltage at those terminals there. Right, okay. Hopefully you'll better see this. No volts. We have a problem. Right. Those were the right ones, yeah. We've got to do some investigation. So, come with me and let's see what we can find. As you can see, it's a bright but frosty day. It's about, I don't know, what time is it? Good Lord, it's nearly 11 o'clock. And the bottom row there of those panels are the bottom 1, 2, 3, 4, 5, 6, the bottom 8 from the right are connected to one Stecker charge controller. So that's the problem somewhere. And just down there, that yellow connection box is where we're going to go first. We're talking 50 volts or 48 volts DC here, and those panels have been wired up for a long time now, could be 10 years. So I'm suspecting a corrosion on the positive somewhere. So let's just go and see what's happening. So this is the first connection box. Let's put the meter down somewhere where I won't stand on it. There we go. So, what have we got? I think this one and that one. So that and that, so that goes up to, no, it's the bottom row, isn't it? That lot is the high voltage. So where are we? So this one, there's a negative down there. Okay, so now where's the positive? Well, let's stick a meter on a few things. Stick the meter there on its side. We're on 200 scale. So, right. we've got the negative there from that lot. Where's the positive? Okay, so it must be on that block there. Problem is we've got two inputs there. 73 volts. What's going on? Let me just investigate. I can't remember, it's so long ago. Okay, I've worked this out. There's the positives. There's the negatives, there's the positive. 73 volts because it's open circuit. So we need to move further along the cable structure to find out where the fault is. So we've got open circuit of 73, fine. Let's go down to the next box and find out what's going on there. Now, I know it's a bit of a mess in there because various things have been added and subtracted and changed and all sorts of things. So let's just see what, you know what I'm like. I'm a bit of an experimenter, and then you move on. Put it like that. Right. I've checked these. Okay. That's still 73. So it's not in there, it's further along. Yeah, I can see I've actually put terminal grease on these terminals here, but there's one there that is looking a mighty iffy. I'm going to have to come back and have a look at that. Okay, because it doesn't look good. So it's always worth inspecting these things. Right, let's move on down the line, as they say. Right, here we can see the beauty of an analog meter. Let me just get in there. So, this was connected to the Stecker charge controller, fine. Can you see this? It's got mighty warm, right? But instead of with an analog meter you can see a needle moving. With these digital ones, especially those Stecker ones that are not backlit all the time, and I don't know whether I can set that so it is, you can't see, or you know, you have to make a positive yeah, we've got 73 there. You have to make a positive action to go over there and press a button to see. And of course this summer has been mega busy, so this might not have been working for several months. So I'm going to hack that back and get some better connections, and again, and put terminal grease on them, and I think we've found the problem. So non-analog meter, busy summer, you can't just see at a glance what's going on, and this is 8 panels, so the panels are wired in series parallel, so there are 4 lots of parallel panels, so that's 4 times, say, 8 amps, 30 amps through that, which the cable's fine, but the connections obviously over time have got a little bit too toasty. Let me sort it out and I'll get back to you. Right, I think I need to get some bigger ones of these. The last ones I had, I used up at the sawmill, so I'm gonna have to get some more, but that'll do for the moment. I'll just have to remember. I tried to use this, which is a big mains high voltage bolted connection, but I couldn't get a connection with it in it very reliably, because even when I folded the cables over, etc., it wasn't having it. It's designed to connect just 2 cables together, and it's got big bitey contacts inside covered in sealant and what have you, but these cables are just too small for it. Anyway, let's go and test it now. Right, let's switch it on. Right, what's going on? No voltage there, no voltage there, no voltage there, so it's still a problem. Let's just leave that on and go back to those connections. Something's odd somewhere. I'm starting to feel we might have a problem with the underground. I'll tell you what we'll do. We have an isolator. Where is it? It's down there. Okay, so we switch that off. And measure the DC volts. We have 72 volts there, nothing there. So we got 72 volts there, right? But when we switch it on, the stecker, I don't know, we got a dead short somewhere. It's a bit tricky, we've got batteries everywhere. 72. Go on, you devil! There. Nothing. We have a dead short somewhere. Which is probably why that cable burnt out. I'm wondering if that stecker has packed up, which would be a surprise to me, because they're normally brilliant. But it's starting to look like we have a problem. So yeah, give me some time and have a think about it. So yeah, it seems like that connection burnt out because there was a dead short. Yeah, right. And we've repaired the burnt connection. We still got the dead short, so it's a matter of being aware of stuff. So I think if I undo one of those screws there, which are the panel screws, yeah, we should then have high voltage, or the correct voltage, 72 volts there, which is open circuit. Don't tell me this is packed up. That will annoy me something rotten, because I do think they're brilliant. Anyway, let's go and get a screwdriver. Okay, that is the negative. Let's put that up there. Can you see that? Just about. Not really. Can you see that now? Yes, you can. Okay, so positive, and let's switch that back on, the isolator. Yeah, we've got 72 volts there. Battery volts here, 56 volts, yes. Okay, we got a stecker that's gone down. Oh dear me. I'll tell you what we'll do before we finally condemn it. I'm going to disconnect. Let me put that out of the way. I'm going to disconnect the positive battery terminal. Okay. And shut the stecker down. Even if this works, I'm not going to be that my faith will have been let me zoom in on that. So system voltage 48. I think you go okay. Right, okay. Let's switch that isolator off. Put that in there. Stay. Switch this back on. That meter don't like it there, does it? We're on DC volts. Yeah, we got a dead short. Okay. There you go. I think we'll just have to, for the next week or so, I'm just going to have some direct connections on that until I can wire up a charge controller for it. So let's just crack on with that. Okay, I've connected the negatives together and we're on DC amps on this meter. Yeah, 16 amps. Alright, grand. And it's making the charge control, the other charge controllers work. You hear that clicking? Right. So that stecker may be a problem. Anyway, I'm going to leave this with you now. We've found the problem. Yeah, indirectly, but that's what analysis is about. And even without those 8 panels, we are now charging at 35 amps, which is nearly 2 kilowatt. Yeah, so strong sunlight, especially this time of the year, it's well worth going round checking everything's working. And it's not so bad at the moment, but a bit later on in the day I shall be wanting that output. So we've got battery volts of 56.4. Yeah, so that at the moment, where are we, that output there, when it's connected, and I'll find an amp meter, will override all the charge controllers. So we don't want to be leaving that uncared for indefinitely. It wants sorting out this week. That way you know, things don't get forgotten and then suddenly in the middle of summer we're overcharging the batteries like mad and nobody's happy. Right. Hopefully you found this interesting. I wasn't expecting the result. I was expecting a fault in the cable, yes, but a fault in the cable caused not by corrosion but by something else. Comments please. Yeah, I mean, alright, some of my connections are, shall we say, a little slightly on the weak side, and I'm going to get some bigger terminals. But the main thing is put terminal grease on everything, especially on the positives on a DC system. Catch up with you soon. Cheers for now.